me just check that you can hear. Can you hear? Can anybody hear me? I don't know if anyone can hear me. Let me just change that. Sorry, I think I just said all that without the sound on. I'm still getting used to the software. I'm using OBS Studio and it's quite overwhelming. Yeah, there we go. Can you hear? Can anybody hear me? Sorry about that. I was muted. It's like a Zoom in the during COVID. Okay, so yeah, to the last stream, what we did was we looked at exam paper from 2023 because that's when the syllabus changed and that's what you're studying, and it's Cambridge that we're looking at, and we're just going to finish off that exam paper and then we're going to move on to the paper 2, the matching paper 2 for that. So let's start with that, and I'll put that on the screen and we can start. There's my files, but we don't need to see that. All right, so we got up to question. If I can open up the questions, there we are. We got up to question 10. So, student uses the internet for their schoolwork to research. What is meant by farming? Oh, no, hang on. No, we got to this one here, question 9. No, we did the brute force attack, 3 types of malware, security solutions. Yeah. So question 9, a company uses robots in its factory to manufacture large pieces of furniture. One characteristic of a robot is that it is programmable. State 2 other characteristics of a robot. And there's 2 marks for that, 1 mark for each. So have a think about that just for a moment while I let my cat in because they're scratching at the door. Come on, in you come. Come on then. She doesn't give up. She was just going to scratch for the whole 45 minutes if I didn't let her in. Okay, so they're quite formulaic with the questions about characteristics of a robot. And basically, they're after one of 2 things. The first one is that it has a mechanical structure or framework, and then the second one, it has electrical components. So if we have a look at the mark scheme, that's the mark scheme for the paper 2, paper 1 mark scheme. Always, as I keep saying, always look at the mark scheme. If you don't know the answer, just look it up. Just look at the mark scheme, and you'll see over and over, the more papers that you do, what they're looking for. And there we go. So it has a mechanical structure or a framework, and it has electrical components. And you can give an example, you know, robotic arm or something like that. Okay, and this is just the sort of stuff that you just have to learn off by heart. There's no way around it. So the next part is give 2 advantages to the company employees. So not the people who employ them, the employees, the workers, for using robots to manufacture large pieces of furniture. So why would, you know, a human want robots to do some stuff? What's it going to help them with? Well, the answer to this one is, well, the employees don't need to lift heavy furniture, so they don't need to hurt themselves doing it. They can be protected from dangerous tasks. They can utilise their skills in other tasks, and employees don't need to perform repetitive or mundane tasks. So there are some advantages of robots. So yeah, just a few though. And then the final part of this question about robots is give 1 disadvantage to the company owners of using robots to manufacture large pieces of furniture. So why might an employer not want to have those robots? Well, there's quite a few reasons. The main one probably is that it's going to be really expensive to purchase them in the first place, and the other is that you have to maintain them as well. So it's expensive to set up. You know, it's not going to be someone, they're expensive. High ongoing costs and maintenance, good. May de-skill the workforce. Well, we kind of know that. And if they malfunction, production will stop. So yeah, quite a few issues with robots not working. All right, let's look at the next question then. So this one's interesting because we're going to have to draw a diagram, but we'll come to that in a moment. So it says a student uses the internet for their schoolwork to research what is meant by farming. State the aim of farming. You can only remember fishing. Yeah, that's okay. That's why you're here, to remember the things that you can't remember. So farming is basically, the aim of farming is to, just like most cyber sort of security risks or problems, is to get people's data or their passwords or to scam them in some way. So any kind of example of that is absolutely fine. Let's look at the mark scheme. We've got to obtain personal details. And then it's got / by example. So that means you could just give an example to get their username and password, or to scam them and get money off them or something like that. So the / is basically or. So you can put one or the other, to obtain personal data or details, or you can give an example. So that's always a handy one to know if you're looking at the exam paper mark scheme. Okay, let's look at the next question, because it says draw and annotate a diagram to represent the process of farming. Now, the process of farming is an interesting one because it's actually a virus. So anyway, they have started putting these questions in since 2023, where you have to draw a diagram. And most of the time what they're after is just kind of boxes with some writing. And, you know, obviously we are going to have to draw, but it does say annotate, which means we have to write onto the diagram. Now, let's just go over what farming is. So I'll go to the whiteboard. Let's think about what farming is. So we know what the aim is. It's to get your sort of username password. But the way that it works is a virus that sits on a computer. And what it does is it intercepts part of the process when you go to a website, and it redirects you to a fake website. So it redirects you to a fake website. So for example, if you type in amazon.co.uk, it will intercept your computer, go into the internet, and it will send you to fake amazon.co.uk instead. So it's quite sophisticated what it's actually doing. And what happens is, obviously, you type that website into your browser, and then the fake Amazon website, somewhere along the lines here, in between it sort of going to the internet, your internet service provider, and getting or trying to get that website, it gets intercepted, and instead it gives you the fake one. So let's think about the process of how we get a website displayed on our computer, because actually this is part of the syllabus and it's good revision as well. So if we're going to get a website displayed on a computer, what actually happens is, and this has actually been a question as well, so it's worth going over it because it's good revision. You type it. So the first step is you type in the URL that you want to go to, i.e. Amazon. I always use Amazon as an example. I know some people hate Amazon. I love Amazon. It's 50 minutes to my nearest sort of big city, big town. And so I literally have to get everything online. So we type in the URL to Amazon. So that's our browser here. and we type it in. And what actually happens is your computer goes to your internet service provider, your ISP. I'm with EE, you might be with BT Internet, whoever. And your ISP has something called a DNS server. Domain name service, it's called actually. And all that is just a lookup where you type in the name of it, like Amazon, and it returns the IP address of Amazon. So I don't know what that is. I'm just going to make it up. 2.1.4.2. Okay. It returns that to your computer, 2.1.4.2, and says, okay, you want to go to Amazon. Here's the IP address. And then you basically use 2.1.4.2 and you say, please give me your website or your HTML for your website. Okay, so that's the process. And again, like I said, this is part of, you need to know this because it does come up. What farming does is when you go to your ISP and say, actually, I want to go to amazon.co.uk, the farming virus that sits on your computer actually intercepts that message. It doesn't ever get through to your ISP, and the fake virus then says, here is the IP address for Amazon, which is the fake one. So it's 9.99.9.9, for example. And then your computer goes and says, okay, 9.99.9.9, which is a fake website. Give me your website. And you're actually on the fake website instead. Now, some of these farming websites can actually look quite sophisticated. They are there to try and get money, extort money off people without them realizing, or scam people. So it's really, they do work. In fact, even Tim Berners-Lee, who created and thought up the World Wide Web, he got caught by a farming website. So if the creator of it can get done with it, then, there's not a lot of hope for the rest of us. So actually, by describing to you what, the process is, I've actually just kind of done the diagram. This is the sort of thing that they're after. So even if you're not sure, you can just kind of draw boxes. You can sort of try and put the process in as well. So that's part 1, that's part 2. You can say fake website here, fake website, DNS server at your ISP, IP address returned, but here is the farming virus intercepts. So I would say that there's quite a lot of onus on you to write what is going on in text, not just think about, how does the diagram look? It's just going to be boxes mainly, If we have a look at their model answer in the MARC scheme, they've got boxes. So we've got malware that sits on the computer. We've got the user computer here. The user types in the web address. The real website's there, but the fake website is actually what we get to, and the user clicks on that link. So they've got to get those formats, the user clicks on or opens the link that triggers the download. Malicious software downloaded onto the user's computer or is already on there. The user enters the website address and it's redirected to the fake website. So I probably went into a bit too much detail, but they're never going to mark you down if you put too much detail. So again, it's just boxes and writing on. Okay, let's move on to the next question. We are near the end of the paper, actually. There's not that many questions left. So we can move on to paper 2 shortly. The student uses a web browser to access data on the internet. Explain the purpose of a web browser. So a couple of things that we can put here. The main one is to render HTML, to take that HTML and draw it, basically. Also, what they can do is they can do things like If you've got JavaScript in your website or in the HTML embedded in it, then it will run that as well. But the main thing is to display and render web pages. So they've got, display web pages by rendering HTML. Yeah. So they've kind of put that into 2 marks, which is a bit strange, but yeah, display web pages by rendering HTML. Okay, storing cookies is one function of the web browser. Give 3 other functions of the web browser. There's quite a lot of these that you could put, literally anything that you can do with a web browser. So, you know, there's loads of different things. Yeah, storing history, that's a good one, yeah. Using websites. So they've already said using websites on the previous question. So, yeah, you wouldn't get an extra mark for that one because they've already stated that one. So if you think about when you open a browser, one is you can have multiple tabs. So even some of the really basic stuff, you've got multiple tabs. Not necessarily store data, but if you think about it, it will, well, let's have a look at their list. There's lots. Store bookmarks or favourites, so that kind of is storing data, but storing data would be too general. Record user history, allow use of multiple tabs, provide navigation tools, so basically going forwards and backwards, provide an address bar, managing protocols, so checking for digital certificates. That will come up in a future paper to check digital certificates. Send the URL to the DNS. So as I mentioned earlier, we've got the DNS server with your internet service provider. It's actually the browser that does that. Send a request to an IP address or web server. Run ActiveScript or JavaScript. So basically run JavaScript. Allow files to be downloaded from a website or the internet. So there are others because a big clue there is it says EG. So example, if you put something that isn't on that list, you should get a mark. Yeah. Okay. A student visits a website that uses session cookies instead of persistent cookies. Explain the difference between session cookies and persistent cookies. They haven't generally asked too much about this in the past. But yeah, see if you can figure out some answers to that. What is the difference between the session and persistent cookies? Yeah, session is short term, good. Persistent is long term, yeah. Think about where they're stored on the computer. So persistent cookies could be permanent and stored, so you can change them next time. Session cookies are changed, are there every time. Yeah, ask you every time. Yeah, that's good. Yeah, good. Yeah, so if we have a look at the mark scheme, that's pretty good. So session cookies are stored in memory or RAM, whereas persistent, so you've said short-term memory, so they would give you a mark for that because memory and RAM isn't in bold and underlined, so that's absolutely fine. Whereas persistent cookies are stored on the hard drive or secondary storage. When the browser is closed, a session cookie is lost, whereas the persistent cookie is not lost or until it's deleted by the user or they expire. So yeah, so that's good. Good what you've put there. That's good. Is that the last question? Yeah, that's the last question on the paper one. Okay, so that is our paper one finished. Let's look at the paper two straight on. No holding back here. We will just go straight on to the paper two. No point in hanging around. So, paper two. 75 marks. It's 50-50 for paper one, paper two. And we've got May, June 2023. This one, yeah, 1 hour 45 minutes, exactly the same. No calculators, etc. All right, so we've got question here. 4 descriptions of stages in the program development lifecycle are shown. Draw one line to link each description to its most appropriate program development lifecycle stage. Not all program development lifecycle stages are used. So we've got analysis, coding, design, evaluation, and testing. So if I can actually get it to maybe, can I get it to write on here? No. That's the highlight. Let's try that one. I can never get this working. Is that the one? Oh, it's doing green. Yeah, no, that's highlighting. It's not that one either. No. I'm not doing very well with this. It's supposed to let me write, but it's not. It doesn't. All right. We'll just have to do it from the first box is 1, second box is 2, third box is 3, fourth box is 4. Good old, yeah. I do need to find a better method to actually be able to write on these in the future, but for now we'll just muddle on as we can. All right, so the first one is develop an algorithm to solve the problem using a structure diagram, flowcharts, or pseudocode. And that is actually design. So to design, this one here is design. Yeah, because you're designing the code, you're designing the algorithm. So that's that one. So the second one, detect and fix errors in the program. That is testing. So we're testing to detect and fix errors in the program. We identify the problem and its requirements. That is analysis. So the third one is analysis. And then the final one, write and implement the instructions to solve the problem. That is coding. So just, yeah, very quickly, they've got evaluation in there. Evaluation isn't actually part of the development life cycle stage. So that's the one that doesn't have anything. It just isn't part of the cycle at all. Just very quickly, if we just remind ourselves of the order of those. So if we think about the software life cycle, the first one is analysis. We have to find out what is the problem, what are we going to do to try and fix it. We're going to get rid of all the stuff that we don't need to look at. So it's not relevant. Then we move on to design, and we don't want to code anything until we've designed, the program, the app, whatever it is we're doing, the database, and then we can move on to the coding. We can actually write the actual thing, and then the last thing is testing. And then hopefully we can release our software. Sometimes you might have to go back to the analysis and think, actually, I need to change that. But if you've done your analysis correctly and your design correctly, you shouldn't have to do that. The only caveat being, if you've got customers who then change their mind, that's usually what happens. Okay, identify 3 of the component parts after a problem has been decomposed. So we're decomposing a problem. What are the different parts? Don't worry if you don't know this. It is a bit abstract, this one. There's actually 4 things, but yeah, don't worry if you don't know this. So the first one is inputs. The second is processes. You could also put outputs, and you could put storage. So if we have a look at the mark scheme for this, there we go. We've got inputs, what is put into the system. Make it a bit bigger, there we go. Processes, so the actions taken to achieve a result. Outputs, what is taken out of the system. Storage, what needs to be kept for future use. And again, those double slashes mean it's or. So you can say inputs, or you could say what is put into the system, or words to that effect, etc. So the whole thing about any kind of system is we've got our inputs. What are we inputting? Could be sensor data, could be a user, could be from a database. We've got processes to analyze, process the data, do stuff to the data, and then we're going to output it to usually the human, and we might need to store some stuff. So yeah, this is an abstract question. I don't think they've asked it since, actually. I don't think they have. All right, now we've got tick box. Tick 1 box to show the name of a data structure used to store a collection of data of the same type. So this is actually A. The answer to this is A, array. A constant is a type of variable that doesn't change once the program started running. A function is a group of code that you can call. And a variable is a data store. Now, if they ever ask you about what is a data structure to name a data structure, you only ever have to say array, because there is nothing else in the syllabus. Now, there might be other things that exist in real life, but in the syllabus, it's always just going to be array. So see that word data structure, always array. Question 3, we move on to data validation. So describe what is meant by data validation. So we've been covering this in the live lessons this week anyway. Last week. Describe what is meant by data validation. 2 marks. What does it do? Oh, yeah, your answers to the previous question have just come up. So good, yeah. I think there's a bit of a delay. I think there's about 10 or 15 second delay between me speaking. Yeah, it's when you check that you've got the right data. Yes, or you are entering the data how you want it to be. Yeah. So you're making sure that the user or wherever your data is coming in meets your own requirements. Because although, like in the lessons that we've done, we've covered how the user enters stuff. It could actually be coming in from like a database or something like that. So yeah, so the answer is really large text there. Validation is an automated check carried out by a computer. Who knew? They've thrown that one in really weird. I don't know why they have put that in, because we kind of know this is, look at this. It's computer science, Of course it's automated. Anyway, to make sure that the data entered is sensible, acceptable or reasonable. So yeah. What is echo check? So echo check is for data transmission. It's not to do with data validation. So validation is making sure that the data entered matches your requirements. Echo check makes sure that the data sent through some kind of medium has arrived correctly. So it's kind of different in that sense. Okay, can you see the answers there? It's just my screen has died. Yeah. It keeps delaying. Yeah, there we go. Right. Okay, next question. A validation check is used to make sure that any value that is input is an integer between 30 and 200 inclusive. Give one example of each type of test data to check that the validation check is working as intended. Each example of test data must be different. So we've got normal test data and the reason, abnormal, the reason, extreme. Now don't worry if you can't remember what extreme was. Yeah, it does take some remembering, that one. I wonder if I can get this onto my whiteboard. Let's see if I can get this onto my whiteboard. There's my whiteboard. Let's see if it will go on. It might not. It might. It does. All right. Let's try it on there. Look at me doing that. Clever. So with normal test data, it's going to be somewhere in between. So we've got a range check. We've got to enter 30 to 200. So we'll just pick something in the middle, roughly, I don't know, 120, 130. Yeah, they only want one example, so that's fine. And the reason, it will be accepted. Oh, no. It's all gone horribly wrong. Oh! Keeps flashing on and off. Will be accepted. Now, abnormal is going to be outside the range. So we could say minus 40. It's less than 30. So it's going to get rejected. So the reason is it will be rejected. And then extreme test data, this is the one that is quite hard to remember, but this is the highest or lowest boundary. So it's either one or the other. So the reason is it's the highest or lowest value that is accepted. So we could go for the highest, we could go for 200. So I'll just say the highest value that is accepted. So it does take some memorization for the extreme one. The other one is boundary, and the boundary one is where it's the highest and the lowest that will be accepted. So 30 or 200 plus, so that's the ones that are accepted. The boundary ones are also the ones that are not going to be accepted. So it would be 29 and 201. So that's not accepted or rejected. It doesn't matter which you put. Again, this comes up in like 95% of exams, probably even higher than that, they will ask you about test data, not necessarily range, although it is quite often. So if we just have a look at the answer here. So they've got normal, they've put 75, but it says, for example, so we can have any. 75 would be accepted. The data lies within the required range and should be accepted. 60, so they've put that as text, but you can put it outside. This is the wrong data type and should be rejected. So they've since changed this and clarified it in the spec that it's not just the wrong data type, it could be outside of the range. 200 is the highest value required and it should be accepted. Okay, let's look at the next question. How are we doing for time? We've got plenty of time. Okay, so explain the purpose of the library routines, div and round. So they don't often ask about this. They usually just expect you to know about them rather than asking you. So div is part of integer division, but it's it's integer division. So I'll just put it on the whiteboard instead of here. So we've got div and we've got round. And how many marks is that? That is 4 marks. So we only have to put 2 things. So div is integer division. And it divides a number with no decimal place. In the result. And then round takes a real or float. It's Python, it's float. In pseudocode, it's a real, but they are exactly the same thing. Takes a real number and rounds it to a specific number of decimal places. I'm trying not to do a circular definition there with rounding. To a specific number of decimal places. Now you can sort of give an example if you want to as well, and I do recommend that. If you do get asked something like this, do give an example. So you could say, I don't know, 10 div 3, so that's 10, so that would be 3. And then rounding, you could say my var is 4.99142, and then we do round my var, and the result would be to how many decimal places that you want to put in. I don't know, 2 for example. So the result would be 4.99. Something like that. Okay, so that is that question. Let's have a look at next one, which is, have we got time for another one? Yeah, we have. Let's have a look at the next one. And the next one is... okay, so we've got errors in code. So we haven't done this in the live lessons. So if you have, this is actually what we're going to be doing this week, if you're watching live. So an algorithm has been written in pseudocode to allow some numbers to be input. All the positive numbers that are input are totaled, and this total is output at the end, and input of 0 stops the algorithm. So basically we've got to read this code and we've got to identify all the errors in this code. And they are very formulaic with this type of thing. Actually, before we do that, let me just show you the mark scheme for the previous question. I think that's important just to show you. So we've got to perform integer division, meaning the whole number part of the answer is retained. For example, div 9 4 is 2. And then round to return a value rounded to a specific number of digits or decimal places. The result will be either be rounded to the next highest or lowest value, depending on whether the preceding digit is a 5. Example of round, for example, 4.56, 1 would be 4.6. Okay. I think what we'll do is we'll stop there. I'm just a little bit cautious that some of you haven't done errors in code. So I think we'll carry on with this one on Friday, and then you can come back knowing that you'll be able to have a look at this sort of question. Yeah, because the errors in code questions are, they are quite formulaic again. They're quite specific with the sorts of things that they'll put in. All right, so we'll finish there for today. I hope that was helpful, and I'll see you on Friday. Next one's Friday, and we'll just carry on with this exam paper. So take care and see you then.